quantum number is the azimuthal, or you can call it the subsidiary, or you can call it the angular quantum number. This quantum number just has only one function, okay, or one of the things it does. It tells us the shape of the word orbital, and from the shape you can be able to identify the orbital. And remember that from your knowledge of orbital, you have the s, the p, the d, and the f orbital. Okay, so this azimuthal quantum number, it denotes the orbital of an electron. Okay, mathematically, the azimuthal quantum number, which is L, is equal to n minus 1. Okay, take note, this is just for what? For the value of L. To get the possible values of this L for the principal quantum number n, the L is equal to 0 going through n minus 1. Okay, this is for what? Possible values. Possible values. So what it means is that the azimuthal quantum number is dependent on the principal quantum number. Okay, so for example, if we have n to be equal to 2, and you are asked to find the value of the azimuthal, if n is equal to 2, the value of this L should be 2 minus 1, right? Which is equal to 1. This is the value. But if I ask you for the possible values of this L, L should be equal to, you start from 0 until you arrive at the value of n minus 1. Remember that n minus 1 is about 2 minus 1, which is 1. So we have 0 and 1. This does not make sense to you, but it will make sense as we keep going further. Let's take another example. Another example. Let's assume, I believe you have written this, or you know what this is. So let's assume again that we know the principal quantum number to be 3, and you are told to find L, the value. Remember, value is just one value. Possible values are more than one, or it could be just one depending on the one you're looking at. So for n equal to 3, what should be the value? What did I say you do? 3 minus 1, n minus 1, which is equal to what? 2. But to get the possible values L, you start counting from 0 until you get to 2. Okay, I will tell you why we are counting from 0. So you have 0, you have 1, you have 2. So the possible values of L when n is 3 is just 3 values: 0, 1, 2. Now, why do we start from 0? We start from 0 because we have the table. This table will clarify you on that. The same one we have for shell. Remember, the same way that the principal quantum number defines the energy of the electron and tells us the shell, the azimuthal quantum number also tells us the orbital, just like I told you. The shape of the orbital, of course, you know the orbital because the 4 orbitals have different shapes. So once you know the shape of an orbital, you have known the orbital we are talking about. So we have the orbitals here, azimuthal here, okay? If the azimuthal quantum numbers, the value starts from 0, we assign it from 0, okay? So we have 0, 1, 2. We can go further to get 3 and 4, 3 and 4, okay? So if the azimuthal quantum number is 0, we assign the s orbital to it, okay? If the azimuthal quantum number is 1, we assign p, we assign d, we assign f. Okay, let me eliminate this because at your level you don't have to know about the g orbital, so I won't talk about this. Okay, so now the same way you know for shell, n defines the shell, azimuthal defines the orbital, the shape. Okay, so the s orbital is spherical in shape, is the azimuthal quantum number. Dumbbell in shape is the what? The p orbital. Double dumbbell is for the d orbital. Then f orbital is a complex shape. Now, there is something else you have to know about the azimuthal quantum number. This azimuthal quantum number can also be used to get the what? Orbital designation. What is this orbital designation? The orbital designation is a combination of the principal and the azimuthal quantum number. For example, if n is equal to 2 and L is equal to 1, if you are asked what is the orbital designation, the NL is equal to 2 L is 1. Remember I told you that if you have something like this, you have this, S, P, D, F, 0, 1, 2, 3. If L is 1, what is the orbital? P. So join it together, you have P. So the orbital designation NL is what? 2P. Does that make sense? Let's try again. If N is equal to 3 and L is 0, and you are asked, what is the what? NL, the orbital designation. The orbital designation is, repeat the principle, it remains like that. The azimuthal, look at the table. What is S? What is 0? 0 is S. So you have what? S. So the orbital designation is what? 3S. Now, this one is for specific azimuthal and specific what? Principal. What if we have something that is not specific? Watch. For example, if N is equal to 3, and you are asked to find the orbital designations of this N. Okay, how do we find the possible orbital designation of this N? I will get the value of L first. What's the value of L? I told you the possible values of L is going to be 0 going through 3 minus 1. Remember, right? So L is equal to 0, 1, 2. Right? So when N is equal to 3 and L is equal to 0, 1, and 2, what should be the possible orbital designation? So the orbital designation NL for this is 3 and 0. 3 and 0 means 3S, right? 3 and 1 means what? 3P, right? 3 and 2 means what? 3D. So the orbital designations when N is equal to 3 are 3S, 3P, and 3D. Try this. If N is equal to 2, what do you think will be the orbital designations? First of all, let's get the value of L, right? What should be L? L should be 0 and 1. Is that not true? So let's combine them. So the NL will be equal to what? 2S and what? 2P. So the orbital designation for this is this. While the orbital designation for 3 is this. So you can try for this. Try for N equal to 4. Get me the orbital designation when N is equal to 4. If you do this, you should get 4S, 4P, 4D, and what? 4F. Okay? So how do you do that? I can show you. I can do a little correction for you so you can be able to know if you are correct or not. So I believe you must get this. For this, I just told you to do this one now. How do you do it? Get for L, right? What should be your L? 0, 1, 2, and 3. Is that not so? Remember, N minus 1. So how do you now get the orbital designations? NL. You combine the 4 with the 0, 4S. 4 with the 1, 4P. Right? 4 with the 2, 4D. And 4 with the 3, you have 4F. So when N is equal to 4, the possible values for the orbital designation are 4S, 4P, 4D, and 4F. Okay? That's the answer. Take note of this. So take note of this. So with this, I believe you now understood what is meant by orbital designation.